Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about the properties of covalent network substances. It's video 14 for Chemistry 2.4 Bonding and Structure, and it follows on from Chemistry 13, which was all about the bonding and structure of covalent network substances. And this video is about the properties. So tends to be the physical properties that we can either measure or observe or see. So, giant covalent networks characteristics are mostly due to a highly uniform structure, a lattice structure, and very strong covalent bonds. That means that covalent network compounds and elements have very high melting points, and because it is difficult to overcome and break these bonds, and so lots and lots of energy is needed to separate the atoms. They're extremely hard. Diamond is one of the hardest metals known to human beings, and but they are brittle. Okay, so they are uniform, covalently bonded, and repeating structure. They are unreactive when solid because many of the strong bonds holding the atoms in place. They normally do not conduct electricity. Now, you have to be aware of some exceptions to this, such as graphite and silicon, and they do not dissolve in water. So, the properties of covalent network substance is a direct consequence of their bonding and structure. They have high melting and boiling points, and they are poor conductors, especially the 3D ones. So, diamond is an example of the 3D structure, forms the tetrahedral structure, and graphite is our main example of the 2D structure with the layers. Okay. So the 3D structures are quite different physical properties to the 2D structures. Diamond is very hard substance, but graphite, now that's the material that's in pencils, is actually very soft. And a typical exam question might ask, diamond has an extremely high melting point. Justify the statement in terms of the particles, structure, and bonding for the substance. So we state that diamond is made of carbon atoms. Each carbon atom is covalently bonded to 4 other carbon atoms in a tetrahedral arrangement. So we've covered the particles, the bonding, and the structure, and this forms a covalent network solid. The covalent bonds between the carbon atoms are very strong and require a large amount of energy to break them. So therefore, diamond has an extremely high melting point. Another example exam question is about silicon dioxide or silica. It also has an extremely high melting point. So, bonding in silicon dioxide is covalent bonds between the atoms. It is made up of silicon and oxygen atoms. Each atom is covalently bonded to 4 others in a tetrahedral arrangement. So, in this part here, we've talked about the particles, which are atoms, the bonding, the covalent bonding, and the structure, which is the tetrahedral arrangement. The covalent bonds are very strong, and therefore they require a large amount of energy to overcome them, meaning silicon dioxide has a high melting point. If the question is about solubility, you can say that those covalent bonds are too strong to be broken by the attraction to the water molecules. So a little bit more about diamond. Diamond is that 3D tetrahedral structure. There are many covalent bonds must be broken to separate atoms if you're going to melt it. So diamond has a very, very high melting point. It is very strong, so it's quite a rigid structure. And all the electrons are held in those covalent bonds. So there's a pair of electrons in each bond. So there's no free electrons to move. So to conduct electricity, you need charged particles that can move. So in diamond, there are no charged particles that can move, so it does not conduct electricity. Compare that with graphite, which is also just made of carbon atoms. So the allotropes of carbon, it also has a very high melting point because there are covalent bonds must be broken to separate the atoms. So very high melting point still. However, it is quite soft because you've got this layered structure, and between the layers are weak intermolecular forces, also known as van der Waals forces. You might see that name come up. We say weak intermolecular forces between the layers, and the layers can slide over each other. So that makes graphite quite soft. If you think about why it makes a good material in your pencils. And it can conduct electricity because the electrons between the layers can move. So 3 electrons are used for bonding. Each atom has only 3. So if I just get rid of all those lines that I've drawn, you'll be able to see that each atom has only 3 bonds. 1, 2, 3. And the 4th one is actually a delocalized electrons between the layers, and those delocalized electrons, which can act as a lubricant, and in pencils, those localized electrons can carry a current, just like in metals. So graphite does conduct electricity. So quite often there's an exam question that has compared diamond and graphite and says diamond does not conduct electricity, but graphite does. So we want to justify the statement in terms of the particle structure and bonding for these substances. So diamond does not conduct electricity is hard. We want to say it's made of carbon atoms covalently bonded to 4 other carbon atoms, forming a 3D tetrahedral arrangement. In diamond, all of the valence electrons in each carbon is involved in bonding to other carbons. There are no mobile electrons to carry charge. Therefore, diamond is unable to conduct. Compare that with graphite, which does conduct electricity. It consists of carbon atoms, each covalently bonded to each other to 3 other carbon atoms in a 2D or layered arrangement with weak intermolecular forces of attraction between the layers or sheets. However, in graphite, each carbon atom is bonded to 3 others in the layers and 1 valence electron is free to move. These delocalized electrons result in the ability of graphite to conduct electricity. So because of the differing structure and the different bonding, diamond and graphite have very different physical properties. And this question is about conducting electricity. This question is also comparing diamond and graphite, but diamond is very hard and graphite is very soft. And again, we explain about covalent bonding for other carbon atoms. For diamond, 3D tetral arrangement. The covalent bonds between the carbon atoms are very strong and hold the atoms in place, making it difficult to break the bonds. Therefore, diamond is very hard. Compare that with graphite. So each of the carbon atoms covalently bonded again, but this time to 3 other carbon atoms in a 2D or layered arrangement with weak intermolecular forces of attraction between the layers or sheets. However, in graphite, although the bonds between the covalently bonded carbon and the atoms in the layers are strong, the forces between the layers are weak, resulting in the layers sliding over each other. Therefore, graphite is a soft substance. So quite often you get questions comparing diamond and graphite for covalent network substances. So this video has been about explaining in terms of the structure and bonding within covalent network substances, the physical characteristics including high melting points, the hardness, why they cannot be shaped by forces because they're just got a very rigid structure, the ability to conduct electricity, and the solubility.